All right, hey everyone, we're going to go ahead and get started. We're here tonight to talk a little bit about the project on morphology as we wrap up and bring some conclusion to, Unit 6 in genetics and heredity. Um, so before we get into the actual project itself, let's just take a few minutes. Let's talk about a little bit of review um, with regards to some of the patterns that we saw in the evolution lesson, and then how that's going to relate to the morphology project. So, some of the objectives that the project is really seeking is that you be able to understand the differences that exist between micro and macro evolution, talk about some sources of evidence that support the theory of evolution as presented to you, and then distinguishing between analogous and homologous structures. Okay, and when we talk about analogous structures, remember, analogous structures are those structures that are related to or showing a similarity um, between organisms. And then, of course, when you look down, those homologous structures are those structures that have a similar attribute that come from an actual common ancestor. So when we're talking about actual lineage, okay, within species, not across species. All right. So when we talk about evolution, okay, and we talk about the patterns of evolution, last week we talked about that natural selection project. Remember, natural selection really is believed to have played a significant role in the evolution of species. Okay, and Darwin and Lamarck and other evolutionary biologists that your lessons have talked about really discussed this heavily, in previous sections. Okay, and when you're talking about survival of the fittest being the theme, the mechanism really of evolution presents very unique challenges for certain species to survive when we look at our planet as a whole that's constantly changing. Okay, so when you talk about the theory of evolution, you're really looking at a suggestion that a pattern exists in the way the process actually works. Okay, so when you look at these processes, okay, you have to really focus on diversity. So, from an evolutionary perspective, one of those main reasons that the diversity of the planet exists is because of the evolution of living organisms. Okay, evolution really is the process whereby all of the species on our planet, both living, past, and present, have been allowed to change. And it's based on the rules of genetic inheritance that we discussed earlier in the chapter. Okay. Um, so some of those processes, okay, when you look at, the timeline of organisms from the beginning of time to now, you have many theorists arguing the theory of gradualism. Okay, those gradualism theorists agree with Charles Darwin, who believed that evolution was a slow and steady process of change over time. Okay, the cheetah, for example, didn't instantaneously become the world's fastest animal. Okay, that speed in those species was attained gradually over time. Okay, and the hallmark of that is suggestive of the process being slow, consistent, but constant. Whereby, another process, those that being punctuated equilibrium. So, some evolutionary theorists like Eldridge and Stephen Gould um, suggest that evolution really occurred by what they determined as punctuated equilibrium. Okay, and their belief was that a species really, when you look at species over time, they really hardly change. Okay, it can be millions of years before species go through any type of significant change, and if the change occurs, it happens in spurts. Now, when you think of spurts, don't think of it as like a day or two. It still takes tens of thousands of years, but it doesn't, when you compare it from a scope wise, it doesn't take nearly as long as those theories of gradualism. Okay, so when this occurs, that organism that mutated, if you will, is most likely to do better and reproduce in the given population. Okay, um, so there's a little bit of difference between the process and the theories that exist. Um, But really, the pattern of evolution that they both suggest is that natural selection, those organisms that have the best adaptations or are best suited to live in those conditions, will pass on those stronger genes to future successive generations over time. Okay. Um, so example in the lesson talked about, Darwin's finches. Okay, each species of finch that he found on his trip to the Galapagos, they all seem to fit the specific environment that they were living in. Okay, and Darwin believed that those finches all evolved from a single common ancestor. However, as those birds came over to the islands, only those birds that had beaks that were best suited for that diet, i.e., the natural selective process, were the ones that would stay there and that would adapt, to those organisms. Okay, so with that, those were some of the highlights from the chapter. Let's go and let's talk a little bit now about the actual project, okay? So the Morphology Project states that basically you've learned that comparative morphology basically looks at similarities between organisms across different species. Okay, so the more similar the anatomical structures are of these organisms, obviously this suggests that they're more closely related. Okay, so comparative morphology as a science can be used to show relationships um, and common ancestry among organisms. So the goal of this project is for you to look at some samples of anatomical diagrams of organisms and compare these organisms to determine if there is a similarity. Okay, so the goal of this project is to take a look at the following images below. Okay, there's 7 images below of different organisms, and make note of the similarities and the differences that you see. Okay, then you're going to actually use your notebook, whatever you wrote down, to answer the project questions. So this really doesn't require any research. This just really requires some understanding of comparative morphology, meaning going through and making sure that you've understood the previous lesson and some of the material that we've talked about here, and then being able to synthesize your response. So it tells you to write a paragraph or two of 150 words that answer the questions below. Now, I'm not necessarily going to do word counts. And in fact, if you want to write a sentence or two just for each answer and under each answer, I'm okay with that. I'm not looking for lengthy answers. I'm looking for your ability to correctly answer the questions and be succinct about answering the questions. Okay, so when you look at these, okay, there's 7 organisms. There's a human, a cat, a whale, a bat, a lizard, a bird, and a frog. Okay, make sure you're taking note of the bone structures of these organisms. Okay, you need to look at these from an anatomical standpoint. And question 1 asks, which organism do you think is most closely related to the human and why? So for this, you need to be looking at the number of bones and the same type of bones that you're seeing of the other 6 organisms as they compare to the human. Okay, so you're looking for one that is similar, that is the most similar between the human and the organism that you so choose. And then be able to explain why you chose that. Okay, number 2, um, which organisms have 5 quote fingers? Okay, so remember, we're looking to do just a finger count here. This is simply just looking at anatomy and doing a count. Number 3 talks about describing the similarities and difference between a bat's wing and a bird's wing. Okay, so again, what we're looking at and what I'm looking for in this comparison is I'm looking for anatomical similarities and differences. Okay, what do they have? What do they not have? Do they have the same number of fingers? Do they have, is one anatomical feature longer than another? That's the kind of material I'm looking for in that question. Number 4, it asks, which animal's forelimb would you expect a dolphin's flipper to most closely resemble and why? Okay, so now you got to think about, okay, well, which organisms here are aquatic. And then from there, draw out your answer and explain why. Okay. And then finally, what does this activity tell you about the relationship between these six organisms? So this goes back to um, the theory of evolution and descent from common ancestry. And that's how you're going to frame your answer. That's what I'll be looking for as you frame your answer to this question. Okay? So that's really all the project is asking, those 5 short questions and your analytics. You can put your answer either in a Word doc and upload it, or you can certainly answer it here in the box below and then send it off to me. If you get stuck with these, certainly visit the virtual office. I'll be more than happy to help you out. And next week we're going to be moving on to another unit, new unit on microbiology. So we're going to shift gears a little bit and actually in the coming weeks start talking about our movement through the different um, kingdoms and phyla of organisms as we start to move towards the end of the year. So with that, have a good week, and we'll be back here next week doing a new project.